So, hello everyone. Today we are going to discuss electromagnetic waves and the electromagnetic spectrum. So, electromagnetic waves basically consist of two words, that is electric field and magnetic field. And as we know that electric field and magnetic field are shown to have a perpendicular direction of propagation, and it is seen that in a wave basically consists of anything which is not having a constant amplitude, but it is changing with a specific time. So if amplitude of electric field and magnetic field is not constant and it is changing with time, then we get an electromagnetic wave. Now, as it is shown that transverse waves without a medium, electromagnetic wave does not need a medium to travel. They can propagate in vacuum, and their propagation speed is equals to the speed of light. And the basics of waves consist of amplitude, wavelength, frequency, crest, trough, that we all know. So they travel as the vibration of electrical and magnetic fields, and in a plane wave it is seen that electric field and magnetic field are perpendicular to each other and also perpendicular to the direction of propagation. So it is shown in this figure that the red arrows shows the electric field variation, and the transverse direction, that is depicted by the blue arrows, they shows the magnetic field. And of course they are perpendicular to the direction of their propagation. Now, if we talk about the speed of electromagnetic waves travel with the speed of light. So we can say that light is also an electromagnetic wave. So it takes around 3 lakh kilometers. It travels around 3 kilometers, 3 lakh kilometers in 1 second. So of course its speed is much large, and we all know that the light from the sun takes 8 seconds to reach the earth. Now, what is waves or particles? Anything which is changing, that is wave. And we know that electromagnetic waves are having a dual nature. They are waves as well as they are particles, depending upon what phenomena we are talking about. For the polarization, for the interference, for the diffraction, we take the wave property of electromagnetic wave, and for the photoelectric effect, Compton effect, then a pair production, at that time we have to take light as a photon or light as particle. So electromagnetic waves are having dual nature. One is particle nature and the other is wave nature. Talking about the electromagnetic spectrum, this is a range of frequency and wavelength where different electromagnetic waves have been categorized. So starting from the radio waves with highest wavelength to the gamma rays with the highest frequency. So if we move from radio waves to gamma rays, we are moving towards the decreasing wavelength and increasing frequency. And there are many other regions including microwaves, infrared, visible, ultraviolet rays, x-rays. So each of these waves are having their specific characteristics because they're having different frequencies and they are having different applications. We will be talking about terahertz waves. Now, in the traditional electromagnetic spectrum, we see radio waves, microwaves, infrared waves, then visible. microwave and infrared wave, there is a gap which is called as terahertz gap, and which we are going to discuss about in our next section. Now, the long waves, as I've already told you, are radio waves are having which are used for the telecommunication, and the gamma rays, which are mostly used for the high energy physics, because they're having very high frequency and hence of course the high energy. Then again, this is the real picture of electromagnetic spectrum. So from spectrum, we can say this is a kind of graphical depiction of frequency and wavelength of specific band different electromagnetic waves. So that's it for this topic.